Okay, here's a short video on how to use the GeoGebra as your dynamic geometry tool to help you test for parts B and C in number 3-44. So first you see that I closed out the algebra section and I got rid of the grid, or the coordinate plane. So I click this button to get rid of that. Now I want to create the two triangles, triangle number 1 and triangle number 2 in part B. So I'm going to go to my segment tool and I'm going to select segment with fixed length. And I'm first going to create triangle number 1. So when I click, box pops up, asks me how long I want it to be. I want my first one to be 3. I'm going to click on the next vertice. I want the next length to be 5. And then I'm going to click on the next vertice and I want the next one to be 6. Then I'm going to go back to my arrow, click the move button, and now I'm going to create, let me do it, create my triangle. And it might take a little pushing because I don't think A wants to move. So you're going to have to adjust C and B, but eventually you want A and D to meet. So there's our first triangle. And I'm going to go up to my text box, insert text, and I'm going to call this triangle number 1. Okay, so triangle number 1. Now, we need to create triangle number 2. So let's start it down here. First length, we need to be 6. Second length, we need to be 10. And then the next length, we need, and I'm going to go up here and grab this and scoot this over so we've got room to work. Move this. Now I'm going to click the next length on E because 12 is going to be pretty long. So I'm going to say we want the length from E to the next side to be 12. So now we have, oops, got to go back up to the arrow and click it. Now we have H that we can move. We have G that we can move. So now we want to try to create this triangle. E is not going to move for us, so we might need to stretch F up here for right now. Pull H. No, H isn't going to move for us. Pull G down. Let's slide this whole thing so we're not on top of our other triangle. Pull H, pull G down. It might just take a little prodding because the first point you make is a fixed point because oh come on, we made a fixed length. So we get G and H to meet. Eventually it'll happen. That looks good. Take E, that's my fixed point, slide this over. Text box, we're going to call this triangle number 2. All right, now the question is, can you create two triangles that aren't similar? So can we move all these sides around and create another triangle with these 3 side lengths? Okay, and the answer is going to be no. I can't get A and D to meet anywhere else but right there. Okay, so now the question is going to ask, is it enough just to know that each pair of corresponding angles are congruent? Or is it enough to know that if the corresponding angles are congruent, can I say that they're similar? Well, let's test these angles. So now we're going to come to our angle tool. We're going to pick it, and we're going to test. So we're going to first measure angle B. We're going to click on A, click on B, and then click on C. It gives me the angle measurement here. Now, if your angle measurements are coming out, I'm going to move this. I click the arrow to move. Coming out with decimals, remember we need to go up to options, rounding. We want to round to 0 decimal places, and it'll give us nice whole angle measures. Now let's finish measuring all of our angles. Now we're going to measure angle A. Oops. Oh, we want to undo that. Hold on one second. All right. I want to start at B, go to A, and measure. We may not be able to do that one. If you're having troubles, start in the opposite direction. So we'll go C, A, there we go, B. Not sure why it was being funny with me. And now we want to measure angle C. So when we're measuring angle, we click on one side, the vertex. See this one again, it's giving me the measurement on the outside. So if you're getting that happening, undo that and start from the other side. We want B, we want C, and we want A. So there's all of our angle measurements. Okay, now let's come over to triangle number 2 and measure its angles. So we want F, E, okay, measuring on the outside again, so that means we have to go edit, undo, start from the other side, here, here, okay, and here, 56. Now we're going to measure from E to F down to H. And now we want to go F to H, back to E. And now let's look at all of our angle measures. Are they the same? Because if in fact they're the same, then it is enough just to know the angle measurements to let you know if two triangles are similar. And in fact, all of my angle measurements do end up being the same. So what now we've kind of shown in in B and C for 344 is that all I really need to know about two triangles, or in fact two shapes, is if I know that if their side lengths have a common ratio, I can say they're similar. If I know all of their angle measurements are congruent, I can say that they're similar. So let's write that here. Here's our discovery. If two triangles have a common ratio, the triangles are similar. If two triangles have, and now let's try to get, oh no, let's not, congruent angles, and let's write corresponding angles, then the triangles are similar. Okay, so here is our discovery. If two triangles have a common ratio, the triangles are similar. If two triangles have congruent corresponding angles, then the triangles are similar. And we might want to go back up here and even say the two triangles have a common ratio. Let's do that corresponding word again. Between corresponding sides, the triangles are similar. And we could even come up here. Let's come up here with our text box. And we are going to put in some symbols. Okay, so first we're going to add in a triangle. We're going to say triangle ABC. Symbol, here is our new symbol under the multiplication division. Similar. So triangle ABC is similar to triangle. We'll add in a triangle. What's the name of this guy? We're going to say EFG. EFG. Okay. So now we've made a similarity statement. We have tested out the side similarity, which if we come back to this text box, let's put that in there. Let's write SSS. Look for our symbol. Where is our symbol? Side. Similarity. Okay. The one down here is called Um, Actually, we only need two. We can say angle, angle, similarity. Or angle, angle, angle. Okay. So now these are where these acronyms are coming from. Two triangles have common ratios between, I'm going to change it again, look at me, between three corresponding sides. If two triangles have three congruent corresponding angles, then the triangles are similar. Now, angle, angle will eventually, angle, angle, angle will eventually get changed to angle, angle because the two angles are only necessary. I mean, because you have your triangle sum theorem of 180 degrees, your third angle will always be congruent if the first two are congruent to each other.